All right. For this, we're going to find the maximal and minimal of z equals 3x plus 4y subject to the following constraints. Constraints are basically inequalities. Now, this is linear programming, and I know when we get into class, we're going to talk a lot about how linear programming is used in the real world, or from your notes, you even wrote it down already. But this is what's known as the objective function. Okay, so basically, the problems we're going to be working with in class are all about maximizing the profit. So if you own a business, how to maximize your profit. And then the minimum part will be how to minimize cost. Now this is just a random function. It probably has no meaning as to profit or cost. It's just an example to show you what constraints are and how we can graph constraints, and then how we can find the values that we need to plug in to find the minimum and maximum values of this objective function. Okay, so just like with graphing inequalities before, we need to isolate y, so get y by itself. So in this case, we'll subtract x from both sides. So we'll have 2y is less than or equal to negative x plus 14. But we need to divide by 2. So again, y needs to have a coefficient of positive 1. So we'll have y is less than or equal to negative 1/2 x plus 7. Okay, I didn't divide by a negative, so nothing changes, so that's my first constraint. And then our second constraint here, same thing, we need to isolate y. So I'll subtract 3x from both sides, so I'll have negative y is greater than or equal to negative 3x plus 0, but I don't need to put that. But again, my coefficient's not positive 1, so I need to divide by a negative 1. Dividing by a negative 1 will flip that inequality, giving me y is less than or equal to positive 3x. Okay, and then lastly, we need to graph this or identify this constraint. So we'll have negative y is less than or equal to negative x plus 2. Again, my coefficient needs to be a positive 1. So we'll have y is greater than or equal to positive 1x minus 2. So here are my 3 constraints that outline my feasible region. Now your feasible region is when we graph those in shade. The feasible region is where all 3 shadings overlap. And then we need to find the vertices of that feasible region. So let's graph this here. Alright, so first one in blue, I'll try to color coordinate here. So I'm going to go up 7, put my dot, and I'm going to go down 1 to the right 2. Down 1 to the right 2, down 1 to the right 2. Alright, and I could keep that going if I needed to, but it needs to be less than or equal to that. So everything below it is going to be shaded. I'm not going to shade very heavily yet, because eventually I'm not going to be able to see numbers and I need to. So y is less than or equal to 3x, so that my y-intercept is 0. My slope is 3 over 1, so I'm going to go up 3 over 1, up 3 over 1. Okay, and I'm going to graph that line. And y is less than or equal to that. Sorry, that's a horrible line, but it's less than or equal to that, which again is below it. And then y is greater than or equal to negative 2, up 1 over 1, up 1 over 1. Okay, and then it's greater than this line, so it would be shaded above. I need to find this vertice yet, so I'm going to go down. The green is down 3, left 1. Okay, and this will be down 1 over 1. Okay, so I have, and again, this is greater than, so it'll be shaded above it. So we can easily identify that this is our feasible region right here. So the vertices of my feasible region are 2, 6, the corners basically. That corner, this corner, which is going to be 1, 2, 3, 4, 5, 6, 4, looks like. And then we have this one, which is -1, -3. So I take those three ordered pairs and I plug those three vertices into my objective function here. So z equals 3x plus 4y. And I see which value maximizes it and which one minimizes it, and that's my solution. So let me move these up here. Oops. So we can hopefully see what we're doing. All right. So let's plug 2, 6 in. So I'm going to have 3 times 2 plus 4 times 6. And that gives me 6 plus 24, so that gives me 30. And then I have 3 times -1 plus 4 times -3. And that gives me -3 plus -12, which is -15. And then I have 3 times 6 plus 4 times 4. 3 times 6 is 18. 4 times 4 is 16, 18 plus 16 is 34. So it looks like 6, 4 maximizes that function. And then 2, 6 is 30, so it doesn't minimize it because it's not the biggest number. The minimize is -1, 3. So 6, 4 is our max and -1, 3 is our min. And that's basically how you do it. So you want this, obviously businesses use this because they want to see what can maximize their profit, what they need to sell in order to maximize their profit, and how much of each, and what you need to sell it at. And then they want to minimize costs. So they need to see how many employees they need on the floor at that time, or in that food truck, whatever it is that they're doing. So I think you're going to like this lesson. Yes, it's hard. It's not hard, but yes, it's long to do, but it's very meaningful, especially if you want to run a business.